Hey, Lorenzo, how are y'all doing? Okay. Let's see, what's going on? Today we will be addressing questions over assignment 20, if you have any. We can also address questions over um, assignment 19 or 21 or basically anything that you have questions over, we can address those questions. Um, just getting to my folders. Let's see. We will have a quiz on Friday. That quiz will be up through assignment 20 problems. I'm not going to give a quiz over assignment 21 just because I'm reserving that day to address any questions over assignment 21. But do expect a quiz this Friday on anything up through assignment 20. Um, I've already spoken with um, Alex. I've already spoken with you about the fact that you're going to be gone on Monday for a UIL meet. What are you doing? What UIL event?
I don't think that's me, sir.
Who was that? Who was that? That wasn't you, Alex.
No, sir.
Can you hear us?
Yeah, I can hear you. Well, never mind then. Um, all right. So, okay. Well, now I'm confused about. Anyways, I gave a poll um, to the other class. I'm gonna give the same poll to you now. A poll is just an opportunity to for you to express your opinion. It is not a vote. We're not voting here. There is not a democracy. This is a dictatorship, and I'm in charge. But I'm just taking a poll. Would y'all rather have y'all know what the difference is between a dictatorship and a dictatorship and a democracy? Do y'all get my joke? It's a joke. I mean, yeah, this is a dictatorship, and I am the dictator, but I'm just kind of making light of the situation. So this is just a poll. Would y'all rather have the exam next week on Monday, Wednesday, or Wednesday, Friday?
Wednesday and Friday.
Okay, that's just a poll. I may just throw your opinions out the window, but I'm gonna consider that. Um, I will be making my final decision about the exam dates um, uh, at some point today or tomorrow. You will get an email by tomorrow about what my if I'm going to be changing the exam dates for next week's exam. The the benefit that I see to moving it to Monday or Wednesday, Friday is that gives you a chance on Monday to ask any lingering questions over that material. All right, let's talk questions. Um, any questions that I can help you with over assignment 20 or any other past or future assignments?
Number 12 on assignment 20.
Number 12 on assignment 20. Okay. And what is your question about number 12? Is there anything peculiar that about that problem that you have a question over? Is there something peculiar, something about this problem that you just, um, or do we just not know how to get started? I'm not hearing you.
I don't know how to get started on it.
All right. Well, um, what I would do, I mean, let me just give you a throwback example. If I had 3 to the x is equal to 1977, what would you do to solve?
Can you switch your screen?
Yeah. If I gave you 3 to the x is equal to 1977, what would you do to start solving? Divide? Alright, so that's going to give you, let's see, 3 goes into 19, 6 times, 1, 7, no, that's going to be, uh, twice, with a, let's see, let's do this. 3 goes into 19 3 times, 6 times, with a remainder of 1, 1, 7. 3 goes into 17 5 times with a remainder of 2, then 27, 9. Alright, so if I gave you this problem right here, you would divide both sides by 3 and to get x is equal to 659. Well, that's what we're going to do over here. The goal is to get e to the 5x by itself. Because if I get e to the 5x by itself, I got another trick up our sleeves to start getting x by itself. But we got to get here first. So how do we do that? We divide both sides by 3. And so that's going to give us e to the 5x is equal to the 659. Now, the problem that I have is that x is way up here in the exponential position, right? So let me give you another throwback example. Suppose I had e to the x is equal to 659. If you've done this assignment, you should be able to do this problem. What do we do right here to start solving for x? What do we do right here to start solving for x?
Natural log.
On both sides, right? Now, the reason that we take the natural log on both sides is so that we can bring this x down in front of the logarithm now as a coefficient. Now, that brings your exponent out in front of the logarithm. Well, we can do the same thing here. We can take the natural log on both sides, and what that's going to allow us to do is it's going to allow us to, by the power rule, bring this whole entire exponent down now as a coefficient. This is by the power rule. So you now get 5x times the natural log of e is equal to the natural log of 659. Okay? So, we want to get x completely by itself, right? So what can we start doing to get x completely by itself? What can we start doing? You tell me.
Try and get rid of the x in front of the natural log e.
Say that again?
Try to get rid of the x in front of the natural log e.
Well, we don't want to get rid of the x, we want to get x by itself. So what do I do to get x by itself?
Move natural log e to the other side.
Okay, so, real quick question, what is the natural log of e?
Log.
No, what is the natural log of e? Use your calculator. What is the natural log of e? Did you bring your calculator to math class?
Is equal
Alex
to
is
1.
making a unicorn symbol. He's pretending to be a unicorn.
It's 1.
Alex was doing this. I'm a unicorn. What was Alex doing? He was saying that the natural log of e is equal to 1. The natural log of e is equal to 1. So, the natural log of e is equal to 1. Do I need to worry about that 1? I mean, if I divide both sides by 1s, so what? Isn't that just the same as this? Are you on board? You with me? Now, what do I do to get x by itself?
Divide by 5.
Divide by 5. Now, am I going to divide 659 by 5? No. You're right. We don't divide 659 by 5 because 659 is within the natural log function. So all we have is the natural log of 659 all divided by 5. Does that make sense? Okay, good. What else can we look at?
Ten.
What number?
10.
10. All right. We want to solve for x. We want to get x equals blank. Now the problem is x is way up here in the logarithm or exponential position. We have the way to get x out of the exponential position. What are we going to do to get x out of the exponential position?
Power rule.
Yeah, so before you use the power rule, you have to take the natural log on both sides, correct? Take the natural log on both sides, and now you get to take this full thing out of the exponential position. Now, it's important to note that you end up with a log and you have all of x minus 1 times the natural log of 3 is equal to the natural log of 13. All of x minus 1 times the natural log of 3 is equal to the natural log of 13. So, how do we start getting x by itself? What can we do to get x by itself?
Divide by x minus 1.
Why would you divide by x minus 1?
Because I
that
thought
would
if
put-
it moved.
Say it again?
Sorry, go. Um, I just thought that since it was moved in front, it was being multiplied, so you just divide it to move to the other side.
Well, if you divide, just think about this. If you divide by x minus 1, then your x is in your denominator. Do you want x in your denominator? No. We want to get x equal to something. Remember, your goal is to get x equal to blank. So what can we do to start getting x by itself? Y'all think about it. What can you do to get x by itself? Could you get rid of the natural log of 3? How?
Divide.
Divide. So that gives you x minus 1 is equal to the natural log of 13 divided by the natural log of 3. Now what?
Add 1.
Add 1 to both sides. And there's your answer. There's your answer. So, don't let, how do I want to say this? I sense that in a lot of students get tripped up by these natural logs of stuff. And they don't, it's like, all right, what is this natural log of 13? What is this natural log of 3? Exactly, what is it? It's some number. That it's some decimal number, so just treat this like you would any other number. It's a number. Maybe even better yet, treat it as a variable. It's a z, it's a w, it's something, right? So, if I had, just for example, to replicate this problem, if I had an x plus minus 1 times y equal to z, and I wanted to get x by itself, well, I would divide both sides by y, and then I would add 1 to both sides. That gives me x is equal to z over y plus 1. That's exactly what we're doing, but instead of having a z and a y, we're having this natural log of 13, this natural log of 3. So you're just doing very basic algebra work. After you take the logarithm of both sides and use the power rule to get this out of the exponential position, you're just doing algebra. You're doing 8th grade algebra to get a variable by itself. That's all you're doing. Does that make sense? Alright, what else can we look at?
Number 6.
Number what? 6?
6.
Now, this, let me ask you a question. Did you try to solve this by taking natural logs on both sides?
Yes, sir.
Don't do it. This is one of those problems you need to recognize that you can solve this problem without the use of natural logs. So I want to do a real quick recall. This is something that we did, either at the beginning of this assignment or in the last assignment. We did things like this. 5 to the x is equal to 1 over 125. How did we solve this problem right here? Or what is the answer to this problem? Anybody? Can anybody tell me the answer?
-3.
Good. 5 to the negative third is the same thing as 1 over 5 to the third, which is the same thing as 1 over 125. So that means that x has to be -3. Well, take a look at this. It's the same thing. You have 5 to 2x, 2 minus x is equal to 125. Well, since you know that 5 to the negative third is equal to 1 over 125, then 5 to the 2 minus x has to be equal to 5 to the negative third. What we have right up here, this 2 minus x, if you could take it one step further, 2 minus x has to be equal to -3. Solve for x. How do we solve for x?
-2 on both sides.
So negative x is equal to negative 3 minus 2, so negative x is equal to negative 5, then what?
Divide by -1.
So x is equal to 5. Now, that should make sense, right? 5 to 2 minus 5, so 2 minus 5 is negative 3, 5 to negative 3 is 125. So what is x? It is 5. So here's the problem. I want to say a problem. I asked you at the very beginning, did you take the natural log of both sides? And you tried that, right? Yeah? So let's see what that does. Natural log of 5 to the 2 minus x is equal to the natural log of 1 over 125. Okay, so by the power rule, this becomes 2 minus x is equal to the 2 minus x times the natural log of 5 is equal to the natural log of 1 over 125. So you have 2 minus x is equal to the natural log of 1 over 125 divided by the natural log of 5. So let's see, what homework is this? This is assignment 20, so if we go to which homework is this? That I'm looking for. I'm trying to remember what homework. I'm looking for something. So it has to be in. Man, did I not? Properties of logarithms. Yeah. All right. So, I guess I didn't have. Man, I need to change. I need to change my homework sets because, um, in your notes, Blackboard, SBC. I'm bringing us to, let's see, fall semester, course content. I need to have some problems over this. Properties of logarithms, notes. Come on, open up. Open up to assignment 19 right there. Very last part of your notes, the change of base property. I should have had some homeworks over this, but I didn't. The change of base property. Log base x of a over log base x of b is equivalent to the log base b of a. So, what we can say is that this is equal to the log base 5 of 1 over 125. That is the change of base property. I'm using this change of base property in your notes. If you have a log divided by a log, and as long as they have the same base, or a natural log, in this case, you can take the denominator, what you're taking the log of in your denominator, that becomes your base, and what you're taking the log of in your numerator is what you take the log of. So, take a look at this. 5 to what power is 125? Well, that is negative 3. So you have 2 minus x is equal to negative 3, which is exactly what we have right up here. So you can see why taking the natural log on both sides is a lot more work, because we have to think about how can we use the change of base property there to solve. So this makes me think I need to change the homework set so that we play around with this change of base property, because it is useful in certain situations. All right. So aside from the change of base property, does it make sense why we can solve this without using logarithms? Okay. 2 of 3. 2 of 3 people had your thumbs up. All right. What other questions do you have?
I think that's it.
Okay. Do y'all understand how to do problems like 16, 17, and 18?
Yeah, actually, can you go over 17? Sorry about that.
17? Okay. Two e to 2x plus 5 e to the x minus 12 is equal to 0. So this is a quadratic type equation, because, why is it quadratic in type? Because if I take e to the x and I square it, we get e to the 2x. So what we're going to do is we're going to let u be equal to e to the x. That means that u squared is equal to e to the 2x. And then I can rewrite this as 2u squared plus 5u minus 12 is equal to 0. And now what I'm going to do is I'm going to solve this quadratic equation. And I wonder if I can factor this. Probably can, because I don't like to use the quadratic formula at this point. You know the quadratic formula. So let's just talk about factoring. 2 times negative 12 is the negative 24. What are the factors of negative 24? Factors of negative 24 that sum to 5. Oh, how about an 8 and a negative 3? So I know I have to have 2u and u, because 2u times u is a 2u squared. To make that 8, I'm going to take 2u and multiply it by 4. To make the -3, I'm going to take -3 and multiply it by u. And there's the factored form. 2u times u is a 2u squared. 2u times 4 is an 8u. -3 times u is a -3u. 8u minus 3u is 5u. And -3 times a 4 is a -12. There's the factored form. Alright, you need to be able to factor these correctly. There was something recently that I was grading. It was a college algebra class. I don't know if it was this class or my other college algebra class, but we were not getting this correct. Something like this, factoring, oh man, it was not pretty to look at. You have got to be able to factor these expressions. You've got to be able to factor them. So there it is. There's factored. If you're having trouble factoring, I would go seek some help. What do we do with it? Once it's in the factored form, we set each factor equal to 0. And what do we get? We get add 3 divided by 2, so u is equal to 3 over 2. That's a positive 4, so subtract 4, u is equal to -4. And then I'll bring my substitution back in, and we have e to the x is equal to 3 halves. We have e to the x is equal to -4. Now, if you don't recognize it at this point, hopefully you recognize it in the next step, but this is a contradiction. You cannot take e to the x and get a negative value. So already I can just throw this out the window. But if you don't see it yet, hopefully you see it in the next step. In order to get x by itself, I would take the natural log on both sides. Then I can use that power rule. And we get x times the natural log of e is equal to the natural log of 3 over 2. X times the natural log of e is equal to the natural log of -4. Alright, take it one step further. We know that the natural log of e is just a 1. So you have x is equal to the natural log of 3 halves. And x is equal to the natural log of -4. And this is, like I said, if you don't recognize it up here, you better recognize it here. You cannot take the natural log of a negative number. It's not in the domain of logarithms. So, throw this answer out. And we're left with the natural log of 3 halves. Now, before you go and circle that, you better check. You better check that you can actually plug this value into your original function. And if I plug in 3 halves, well, natural log of 3 halves is going to be some positive answer. Positive. Alright, it's all going to work out. And I think we're done. Natural log of 3 halves. So Alex, does that answer any lingering questions over this problem? Okay. What else can we look at?
Can we go ahead and look at number 16 too?
Same assignment?
Yes, assignment 20.
Alright. Look, we've done 17, so I'm gonna have you talk me through this. You do it. Tell me what you've done so far and what you need to do to finish out the problem. E to 2x minus 2e to the x minus 3 is equal to 0. You tell me what to do. Can't hear you.
U equals e to the x.
Okay. So what do I do with that?
Substitute it.
Okay, keep going.
And then you'll get a u squared minus 2u minus 3.
Okay, now what?
You find the factor, yeah.
Factor it. Alright, tell me, what does the factored form look like?
I got u minus 1 plus
Keep talking. What?
u minus 1.
Keep going. Keep talking.
This is where I kind of got stuck at.
Alright. You have u minus 1. Alright, first of all, that's not correct. Here's what you gotta think about. What are the factors of c, which is a negative 3, that sum to b, which is a negative 2?
So would it be
What things
u plus
multiply
1?
together to give me negative 3, but add together to give me a negative 2?
Plus 1 and minus 3.
Plus 1 minus 3. Good. So it's u plus 1, u minus 3. Now what?
Equal them to 0? Oh yeah, you already
Equal what equal to 0? What equals 0?
u plus 1 equals 0, and then u minus 3 equals 0.
Okay, now what?
And then that would give you u equals negative 1, and then u equals 3.
Okay, now what?
Check to see if they work in the equation, right?
Say that again?
And I don't check them.
Check them. Well, the problem is you're telling me what u is, but the original equation was in terms of x.
Now, are you gonna substitute the u and then equal it to ex, or yeah, that.
Now what?
Now you substitute them into the equation, or you solve them, right? You need to get
Yeah,
x
solve
by
for
itself,
x.
yeah.
How do I solve for x?
Natural log.
Natural log both sides. Okay, how does that help me?
Then you can do the power rule.
Now you can apply the power rule. Okay, now what?
Natural log and e equals 1.
So I basically can just say that we have this, right? So what are my answers or answer?
Well, since natural log can be a negative, it should just be x equals natural log of 3.
Good. You cannot take the natural log of a negative number. So we throw that solution out, and the only solution that we have left is the natural log of 3. Good, Alex. Made you talk your way through it. Does talking your way through it help? Making me talk your way through it? I was I was not and still not good at sports, um, but so I don't know. I mean, I can remember my coaches yelling at us, "Run faster! Work on that layup! Practice your free throws." Um, wasn't very good, but that's what the coach did. He made you work, right? So, in some regards, I consider myself a math coach. I'm gonna show you how to do things. I'm also going to, if I have the opportunity, to make you do things, and I might make you. I hope. My goal is not to make you feel uncomfortable, but um, I'm going to push you to regurgitate information, to talk about it out loud. All right. Anything else I can help you out with in the remaining 2 minutes that we have left? Whereas, Alex, I'm gonna remember that. Holding up a one like this. When my 3-month-old daughter is young enough to be in the unicorns, we'll be running around the house like this. All right. Well, you want to see a picture of my daughter? All right. What's up? What are y'all doing? Oh man.
Your conference is scheduled to end in 2 minutes.
This is all my this is all my camera is good for. There's a good picture. And then our son William, what is our son William up to? Let's see. Where's a good picture? William. Where's another good William picture? Oh man. Stuffing his face with a donut. Mm-mm-mm. Kicking back. Lounging in the chair. Anyways. Alright. I will see y'all on Friday. Feel free to email me if you have any questions. We'll have a quiz on Friday. And I was busy yesterday updating a lot of grades. Everything should be graded, including quizzes. So be sure to check out those graded quizzes. You can see the grades in GradeScope. Alright, I will see y'all later. Take care. And see y'all Friday. Bye.
Your conference is now over. Goodbye.